Guys, we are back. So in this one we are going to actually create the camera control. Okay, the camera controls. All right, so uh, in the previous video we actually parented the camera to our player. Okay, so I'm going to drag the camera out of the player back so it's on its own. All right, so the camera is going to stand on its own now, and we are going to create controls. So we're going to write a script to actually control the camera's behavior. All right, so now what we're actually going to do is, let's right click. We're going to create an empty game object, and let's reset the position. Okay, so we want this game object to be right where the player is. All right, right exactly where the player is. We are going to name this camera holder. All right, so this is going to hold the camera, and then we are going to right click and then create another empty game object within this game object, and we are going to say camera center. Okay, so the center position for the camera, so or let's just name it center. All right, so this is going to be the center position, and we're going to drag the center position up. In fact, I'm going to set it to be 1. All right, 1 unit up, so it's going to be somewhere around the character's waist. All right, so the next thing is we're going to drag our camera itself and drop it right in the center. Okay, so we have that set, everything looking nice. So what we can do is we can drag the camera a little bit, position the camera a little bit to the side of our character. All right, so yeah, something like this. It's good. Let me see the game view. Let's come forward a little bit. I think it should be forward a little bit. Yeah, I think something like this looks good. So that's it. So the next thing is go to our project view, and then let's go to our scripts folder. Inside our script folder, we go to the camera folder, and right here we are going to create a script. All right, so C# script. We're going to name this camera controller. All right, so this script is actually going to control our camera behavior. So our camera controller script. So once this script is created, click on this camera holder component game object here. We are going to drag the camera controller script as a component on this camera holder game object. So double click to open this guy up. Now once it's opened, we are going to start something now. What we are going to do is we are actually going to create a system.serializable class. So system.serializable public class. We are going to say this is going to be our camera settings. All right, so this is going to hold everything pertaining to our camera settings. So what we can do is we can say this is a serialized field, and then just say public camera settings, just like we did in the other ones. And then in the other scripts we can say camera settings. All right, so that's our camera settings. Now in our class we are going to create some variables we are going to need. First thing we're going to need is first let's create a header. So I explained to you what this header does. Okay, so inside the header we are going to say camera move settings. Okay, so what this header does actually, let me just create one public variable here. We're going to need public float. We're going to need the camera zoom speed, how fast the camera is going to zoom in on our character. So that's the first variable. Let's just save it, and let me explain to you what this header guy is going to do in our code. So yeah, so you could see we have our camera settings serialized class created. Now you see the header over here. It's going to create like a nice heading for us in our inspector over here. So it's saying camera move settings, and it's going to actually store all those settings. I mean those variables we're actually creating over here, all right? Zoom speed and all that. So you see the header created like a nice heading for us. Now the next thing is we're going to create another variable called, it's going to be a float, the move speed of our camera. So how fast our camera is going to move, all right? Then the next thing is our camera is also going to be rotated, okay? So the rotation speed, right? Guess right. So the rotation speed, we are going to also set that to 5 for now. Okay, we are going to play with these values to get a reasonable value. Now we're going to say we're going to get public and then float. We are going to get the original field of view of our camera. So the field of view of our camera, all right, the viewing angle of our camera. So we are going to set it to be 70 for now, and then we are going to have another field of view, which is going to be the zoom field of view. So when we zoom, the field of view is going to change. Okay, our camera field of view is going to change anytime we zoom. So you know, this is a bow and arrow kind of like game. So what we want to do is, now when the user right click, it's actually going to zoom in on the character and then show the crosshair, the aiming crosshair and all that. So now the next thing is the mouse sensitivity. The mouse sensitivity, so how sensitive would the mouse be? So we have the mouse X sensitivity. So rotating the mouse along the X axis. Okay, the sensitivity, sorry, it's very difficult to pronounce sensitivity today. All right, so the sensitivity of the mouse, how sensitive the mouse is going to be when it's rotating along the X and Y. So for both Y and X, so sensitivity for both X and Y, it's all set to 5. And then we are going to have a maximum angle. Okay, the mouse can move on like the X axis, so we have the max clamp angle. So, and we are going to set that to 90, and then we're going to have another public float, and then that one is going to be the minimum clamp angle for our camera, and that's going to set to -30. All right, so I've played with these values and I think it works perfectly. So yeah, so that's it. So the next thing is we're actually going to create another serialized field. So let's kind of like create a comment over here. I'm going to say this handles camera settings. Alright, and then the next one we're going to create over here is another system serializable field. Now this public class name is going to be camera input settings, and then we have that done. So take this guy to a new line. Looks so then first we are going to have a public string, and that's going to be our x-axis. Okay, or we'll say mouse x-axis. Okay, our mouse x-axis, and that's going to be that's going to be mouse x. Okay, so these are going to be the input corresponding to the input axis mapping in Unity, like how we did for moving forward and moving backwards, where we had like the horizontal and then the vertical. All right, so now we have the mouse y axis. All right, so a minute. Alright, so we are going to add that here. So that's going to be our mouse Y, like this. Now the next one we're going to have is our aiming, okay, input, okay, and that's going to be fire 2, okay, and yeah, this looks good. Now we need to actually register this as a serialized field and then create a public instance of this class, the camera input settings class, and then we're going to say let me just say input settings, and then we are done. So now we have our camera input set for us perfectly. It looks good. Now we need to have our center, okay, our camera center. We say transform, and then we're going to say center, so the center position, and then transform a target. So the camera is actually going to target the user, so the target is going to be the player, so the camera will have to follow the player. And then let's have these two values, a float value, one for camera X rotation, okay, we are going to set it to 0 by default, and then the next one is going to be a camera Y rotation, set that guy also to 0. Alright, so we have these guys set up for us perfectly. The next thing we're going to do is we need to also create a variable for our camera. Alright, so we need to access our camera, so we'll say right here, we say main, we'll create so camera, and we say main cam for camera, and then let me take away this E, so main cam, and then what we're actually going to do is we are going to say main cam is equal to camera dot main. Okay, the next one is we are going to say center is equal to transform dot get child, and we're going to get child 0. Okay, so the first child of the camera is actually our center. All right, remember we created this object. Yeah, all right, sorry for the distraction. So remember we created this object. So you go into Unity, we had this camera holder here, and then this center object right here, right, which was right around the waist of our character. So this is the first child of camera holder, which is actually storing our camera controller script. So it's going to get that guy. All right, so after getting the center game object, the next thing is we need to get a reference to our target. So what we actually target, which is our player. So our target would be equal to, so now inside our game object, we're going to do game object. We are going to say game object dot find, okay, game object with tag. All right, so we're going to find any game object tag that's player. All right, so that will be the one we are looking for. We are going to access the transform of this game object. All right, so now we have this done, everything set for us. Now everything looking good now. All right, so the next thing we have to do is actually create our function to rotate the camera and then follow our player. So the first thing we are going to do is right down here below our update. First thing we are going to create a late update function. So late update, So a late update is actually a Unity function. So I'll explain to you when we start the implementation why we need late updates. So the first thing we're going to do is we're actually going to create a function to follow our player. So we are going to say follow player. So creating a function to do. Now what we are going to say is we're going to say we're going to create a vector 3, okay, and that vector is going to be move vector for a camera. Then we are going to do vector 3 dot left. So we are going to left the so we are going to actually left the current transform position of this game object, all right, to wherever our player is going to be. So target dot transform dot position. All right, now we are going to do that, and we are going to actually do that within the move speed variable we created over here. So how fast our camera is going to move. So we are going to access the camera settings, okay. So we actually need to access the camera settings. So where do we, all right, yeah, so we're going to access the camera settings class, and we're going to say dot move speed times time dot delta time. So time dot delta time will actually make this smooth, all right. So that's Unity helper function that gives us the time between 2 frames. It took for 2 frames, all right, so we can get that smooth interaction, all right. So our follow player is done. The next one we actually going to do is the rotate camera. So we are actually going to write the code to rotate our camera. So we are going to say rotate camera. So we need to add the void keyword here because this function has no return data, so there's no return type, so it's void. Now what we are going to do is we created our camera X rotation. We are going to say that value plus equal to, now we are going to say input dot, okay, get axis. We're going to get the axis, and we are going to say input settings dot. So how did we name this guy in the input settings? Mouse X axis. I think that's how we name it. Mouse Y rather. So mouse Y axis, okay, times, okay, the sensitivity value of our mouse. How did we camera settings that, okay, so mouse Y sensitivity, all right. So we camera settings dot mouse Y sensitivity. The next one is going to be for our camera Y rotation plus equal to input dot get axis. Now the axis we are going to get is within our input settings is going to be our mouse X axis, and we're going to say times camera settings dot mouse X sensitivity. All right, we have this done, and I can see the spelling of the mouse over here. I made a mistake. It should be lowercase. I don't know whether I did the same mistake here, so lowercase. All right, so we have this down. Now the next thing we're going to do is we're actually going to do something with the camera rotate values. Camera X rotation, we are going to say it's equal to mat F. So I'm going to explain what this actually does, so don't worry when you're confused. Okay, if you feel like you are getting confused, don't worry, just ride along with me. At the end of this video, I think you'll be fine. All right, so we actually want to do something with this value. Okay, we are clamping this value. Remember, in the camera settings we did a maximum clamp angle and then a minimum clamp angle for this value, this variable. So we want to clamp this variable between the minimum and maximum. All right, and the max clamp angle. All right, so no, max, this should be max. All right, and the max clamp angle. So we are clamping the camera from min to max. All right, so once this is done, the next thing is to focus on our camera rotation for the y. Camera y rotation is equal to, now we are going to do a mat f dot repeat. We're going to repeat so our camera y rotation, we are going to repeat the rotation. We want to repeat it 360 degrees. So what happens is when you rotate your camera along the y axis, it goes 360 and comes back and continues that 360 cycle. All right, now finally I'm going to create a vector 3 and I'm going to say the rotating angle for our camera now is going to be a new vector 3, and this vector 3 is going to help us get this angle. So we are going to put our camera rotate x and y values here. So the first one is the camera x rotation, and then the next one is our camera y rotation. Sorry, should be y, so I just have to change this guy to uppercase y, and so y. And then we don't want to rotate in the z-axis. Okay, so we are not rotating the camera in the z-axis. Then now we do a quaternion, and then we are going to say rotation is equal to, then we are going to do quaternion dot slep. Okay, so now I want to slep the center. Okay, dot transform dot local rotation. All right, so and we are going to do quaternion dot Euler. Okay, and then now we are going to get the angle, the rotation value from our rotating angle, and then we are going to do this in time of a camera settings. Okay, dot so this will be rotation speed times time dot delta time, and that gives us our smooth rotation. Now we need to apply this rotation to the center object, which is the center dot transform dot local rotation is equal to the rotation that we get. So now this script over here is going to handle our camera rotation. So what actually happens is we created this local variables here, camera x rotation and camera y rotation. So what's going to happen is these variables are taking an input for us. Now this input is going to come from our input settings variable here. So this is going to be actually created in Unity. So if we go back to Unity and then editor, project settings, and we go to the input manager here, you could see we have mouse X and then we have mouse Y. Okay, so this mouse X and mouse Y correspond to the mouse movement. So moving the mouse left to right is mouse X, moving the mouse up down is mouse Y. Okay, so now when we move the mouse up, we want to rotate the player. Okay, we want to rotate along this axis, the X axis. Moving up, we rotate along the X axis, and moving left and right, we rotate along the Y axis. So if you look carefully at the code down here, so after getting these inputs, look carefully at the code down here, we get the input axis over here. All right, these two input axes, and then we multiply it by the sensitivity. All right, now the X rotation will now be the Y axis because Y is up and down, and it's rotating along the x, and then the y rotation will be x-axis. So you can see that's why we replaced y x with y over here for the x rotation, and then y with x over here for the y rotation, because when you look over here, moving like this is y mouse y. Okay, moving up and down is mouse y, and moving up and down means rotating on the x-axis. So we have to convert mouse y to a rotation on the x-axis, and moving left and right is rotation on the y-axis. So we have to convert from the mouse x to a rotation on the y-axis. All right, so we have that set, and we get these values and multiply it by the sensitivity. How sensitive do you want the mouse to be? So we created the sensitivity value over here, which we can change. Okay, we can play around with those values, and we have a rotating angle also, so over here we clamp the values. All right, so the user doesn't rotate over our character. So we don't want the rotation to be continuous, and then like the camera will rotate and then come down and then go like that in a loop. So we have a clamp, a maximum angle you can reach down and below on the with the rotation on the x-axis. Okay, so with the rotation on the x-axis, so we clamp the rotation. Okay, so it doesn't go beyond 90 degrees and then minus 30 degrees. All right, and the final thing is we also repeat the rotation over a 360 period in the y rotation. So in the y rotation, what we want to do is we want it to move 360 around our player. So no matter what, it should move how many times, as much as it can. All right, and we don't have a problem with that one. And then we set this as a vector and we store it here, and we don't want any rotation on the z-axis, so we set that to 0, and now we are actually moving to that rotation value in a set time. All right, so you could see we have everything done perfectly now the final thing is, I think we'll have to handle the zoom feature. All right, so when the user right click, all right, we actually want to zoom our camera, so we are going to say zoom camera. And this video is getting really long. Right, so zoom camera. So now inside the zoom camera, we're going to say if input, right, so dot get, excuse me, button. We are going to say input settings dot the aiming input is pressed. When that value that is pressed, this is what we're actually going to do. So first we're going to say our main cam we just created. We're going to say the field of view, main cam dot field of view is equal to matf dot lep. So we are going to lep our camera. So we are going to say main cam dot field of view. So we are going to actually change our camera's zoom settings. All right, so we are going to say camera settings dot zoom field of view. So we are going to move from its current field of view to the zoom field of view, and then we are going to say we are going to do that in the camera settings dot the zoom speed. All right, the zoom speed variable, and then we are going to do that and multiply that by our time dot delta time value. Okay, so now we write an else statement, and now with the else statement we're going to say main cam dot our field of view. So our field of view will be equal to matf dot lep again, then we're going to say main cam dot field of view again, and then we're going to say our camera settings, okay, dot. Now we don't want the zoom field of view, but we actually want to move back to the original camera field of view. That's if we are no longer aiming. All right, so we're going to say camera settings dot, and then the final one will be zoom speed times time dot delta time. So done. looks good. So we are going to save this. Now we have to make use of this function. So we actually want to call everything, okay, and then make sure everything is running perfectly. Now we are going to say if we do not have a target, okay, we want to return from this function. That means we don't have a target. Then now we are going to call the rotate camera function, and then we are going to call the zoom camera function. So if you don't have a target, we are actually going to break out of this. And in late update, we are also going to do the same thing if we do not have a target. Okay, we are going to return out of this function, and then seems like I have a call or something. I'll be back in a minute. So sorry guys for that disturbance, I'm back. All right, so I was saying, yeah, so if we do not have a target, we have to return out of this function, and then what we are going to do actually is okay, so there's something I want to do here. I'm thinking that will be the right choice. So first we're going to create another function here. We are going to say find player. Okay, this function is going to be called find player. Right, so now this is what we are going to do. We are going to say target is equal to, so what we just did in start, we're actually doing game objects that's find. So we are going to copy this guy. So copy, sorry, I just messed up. All right, so I'm going to paste this over here, and now we are going to replace this with the find player function. Okay, we're going to say find player, so we don't repeat code, we don't duplicate code, we use the function. So over here we are going to say if there is a target. Okay, this is what we are going to do. If there is a target, then we actually want to follow the player. Okay, and then if there is no target, then we are going to find the player. Okay, we're going to look for the player. All right, now this is what is actually happening here. Right, okay, now the reason why I'm following the player in late update is because the camera is responsible for rendering our 3D scene. The camera is responsible for rendering all the objects in the scene. It will be advisable to move the camera after everything has been rendered. So if you read the Unity documentation, they'll tell you that late update runs after everything has been rendered. So I think if I open my browser and then with my browser open, let's look for Unity late update. Yeah, so late update function. So you can see difference between update, fixed update, and late update. We have some funny link here that describes everything for us. So you could see describing all the Unity functions. The late update is also called per frame. It's called after all other update functions, time delta, time, or it's called after all other update functions. All right, time delta fine will provide a time interval for the late update. So you see, so late update is called after every update is called. So after everything is done in our scene, that's when we actually want to move our camera so that we don't have weird behavior. So every object is rendered in our scene before we actually move our camera. All right, so basically that's that. Now one last thing I would like to do is I would like to execute this script in edit mode. All right, so I'll say execute in edit mode. Now with this set, we have to be very careful because it means this can even crash Unity when we save this and then we don't do certain things right. it can crash Unity. So like rotating the camera will be rotating all throughout. Now the reason why I'm doing this is because I want to be able to target my player even when I'm not playing the game. I want the camera to be positioned well. So I'm going to say if not application dot is playing. Okay, so if the game is not playing, what we are going to do is return out of this, so that we don't run this rotate camera and zoom camera code. Alright, because this can break our game and crash. So we are saying if we are not playing the application, then return out of this. Okay, so if we are not playing our Unity application, it should return out of this. But if we're playing, yeah, I'm fine. Alright, so we're done. We save this, and then let's head back to Unity and see what happens now. Seems like, alright, we are back in Unity, and then it seems like I'm getting a null reference error. So let's double click. Yeah, so you see execute in edit mode. So this is executing. Alright, so now let's select our player, and then let's add a tag of player. Alright, so you can find our player now. Now if you look over here, which in the find game object, we say game object dot find game object with tag. So any game object tagged as player is what we are looking for. So we have to tag our player as player so we can find our player. Alright, so that's done. We go back to our camera holder. In our camera holder, we have all our settings here for us. I think this should work pretty fine, but if not, we're going to change them anyways. So now we have our rotate camera and everything. So our follow player, this also takes the position of this camera controller and then moves it to the position of our player within some particular time. So the speed we set times time the delta time, and then we set the position of this camera to this vector. So the left function will help us smoothly transition player there. So let's play and see how far this goes. So enter into play. Now you could see I'm rotating my camera can rotate around my player can walk forward, but you see when I rotate my camera, you see the player is supposed to rotate with the camera. Alright, so when I rotate my camera this way and I start walking, the player should walk in the opposite direction, but the player isn't behaving that way. So we have to fix that. Okay, so we're going to fix that. Actually, I think the way to fix that is to do that in our user input script. All right, so what we're going to do is so let's just go to our script and then our input system. So over here we're going to take we'll say public, and we're going to say we're going to look for the camera center position. All right, so we want that center position of the camera. So we'll say the transform, then we'll say cam center like this. Okay, then we're going to get that, and then in fact I'm as well going to get a reference to the camera. So I'm going to say or basically just the center position. All right, so I'm not going to make it a public attribute again. I'm just going to do cam center is going to be equal to camera dot main dot parent. Okay, dot transform dot parent. All right, so transform dot parent. All right, so it's going to give us the parent, which is the cam center. Okay, Now what we are going to do is we're going to create a function here and say rotate to come view. So we are going to rotate the player to the camera view, all right, to come view. And then right here, this is what we are going to do. We are going to say transform. Okay, now we already have the come center transform. Okay, so what we're going to do actually is to get position. Okay, so we say vector 3 come center pose. Okay, come center pose, and we're going to do come center dot position, get the come position, and then we're going to create another vector 3 look. Okay, look point. Now before we create look point, there's a few things we have to do. All right, so over here we're going to say create a variable. All right, we're going to say this variable is going to be public look distance, or yeah. So I think I'm thinking we actually need so what I'm going to do is I'm going to actually make this look nicer by creating a header. Okay, so I'll say I'll call this, I'll just create a header. Inside the header I'm going to say camera and character syncing. Okay, we're kind of like syncing the camera and the character together so everything looks smooth. So we are going to say public look distance. We are going to set that to be equal to 5, and then we are going to say public. So this has to be a float. So why do I keep making mistakes? Sounds like, all right, so public floats, and then we say this will be look speed. Okay, how fast the character is going to look, and then let's set that to like the same 5. All right, then now with that done, we're going to say vector 3 the look point is actually equal to the come center position, so come center pose, and then we are going to do plus. Okay, come center dot transform, or the forward, no, dot forward, yeah, the forward direction times our look distance. Okay, so after that we are going to create another vector 3, and then we're going to say direction, or look direction is going to be equal to now we have our look point variable here. We're going to say our look point variable minus our player's position, transform dot position. So this will give us a directional vector. Okay, and we can use this directional vector to get the rotation to which the character must rotate. So if you look at the center pose of the character, the camera center pose is facing in the forward direction as the player. All right, when the player is moving forward, and this, so when we rotate the camera, the center pose rotates. So when it rotates and faces this direction, okay, like this way, for example, it rotates this way. Okay, and then let's switch to local. Yeah, it rotates this way, facing this direction. Yeah, the character also have to rotate this way and face the direction of this guy. So we are actually using what we call we set a look distance, okay, which is 5. So we get the forward direction of that center position times the look distance, and that will create a vector in front of this guy here. we create a vector in front somewhere here. Now once we create that vector, we are going to store it in the loop point. Now that loop point vector, that vector we create in front here minus our player position will give us a directional vector which can be used to get the rotation. All right, so Control Z to undo what we just did, and then let's go back to our script, and then yeah, so that will give us the directional vector. All right, you can spend time to read about vectors. That will give you a better understanding of what I'm talking about. All right, about directional vectors and rotational vectors and all that. So now quaternion, and then we are going to say our look rotation. Our look rotation is equal to quaternion. So Unity has this look rotation method in the quaternion class. Now what this look rotation value does is it takes a vector. So the vector is our direction vector, okay, and it converts this vector into a rotation value. Now we need to reset some of these guys. All right, so look, we need to reset some stuffs here. So look rotation dot x is equal to 0 because we don't want to rotate the character in the x direction. We only want to rotate the character in the z, all right, not in the x. All right, we only want to rotate the character in the y, not in the x and z. All right, so now we are going to do a quaternion. We are going to say final rotation is equal to quaternion dot left, and now we are going to left the character's rotation. So transform dot rotation, comma, and we're going to left to our look rotation we got, and then we are going to do that within time dot delta time times our look speed. Okay, how fast the character is equal to 10, and then now we need to actually set the value to be equal to the character's transform dot rotation. So we take the final rotation and actually apply it to the character now. So now that's the trick. So this is going to do the trick for us. So the quaternion dot look rotation takes a directional vector and gets a rotation for us out of that directional vector, and we use the quaternion left function to apply the rotation to our character. Now in order for this to work, what we are going to do is that in update, okay, we are going to do a check over here. We are going to say if input dot get access. So if we are pressing on forward or strafe, so we are going to do if input dot get access, the forward input is not equal to 0. That means the user is actually pressing the keyboard, or the user is also kind of like input dot get access, the user is also strafing. So we're going to say input dot strafe, oh sorry, not sprint, we need a strafe input. If that is also not equal to 0, that means we can actually rotate to the cam view. So we rotate the player to look at where the camera is actually pointing, the direction in which the camera is also looking. Now what this is actually going to do is it's actually going to rotate our player anytime the player is moving forward, left or right. So if we are not moving, don't rotate the camera. So let me show you an example what that means. Let's play. So now we are not moving. When we rotate the camera, the character doesn't rotate with the camera, but when we start moving and we rotate the camera, the character automatically rotates to face the direction in which the camera is rotated. So that solves the trick for us. So now we have everything set. We have walking, camera rotation, character facing the camera rotation. We can run, and then we can strafe. So once we are strafing, we can rotate the camera, we can strafe. Look at that, everything works perfectly. Walk forward, shift sprint, There we go. So we have simple movement. When we stop, you can just rotate around the character, and then just when you start moving, the character actually starts facing the camera direction. So basically this has been very informative. I advise you guys to kind of like practice more. This has been very long video, but it was very educational, and I know a lot of you guys have learned a lot from this video. So I advise you guys to actually spend some time with the code, rewatch this video. It's a very long video, but rewatch this video, try and understand some of these concepts, practice more, and then try and see if you could actually make it on your own. All right, with that you have a broader understanding, you'll be a much better person, and then you also improve. All right, so I'll catch you in the next one. Maybe we will handle maybe camera collision, camera wall collision, and some other fancy stuff. All right, I don't know whether we might do that, but I'm thinking maybe we might tackle other things also. So let's just hope and see. All right, bye, and see you next time.